Hi friends, in previous videos we have discussed about decimals, types of decimals, okay, and we also discussed about converting different types of decimals into rational numbers and rational numbers into decimals, right? And also we have discussed about what is period and periodicity, and we have expressed about expressing this non-terminating recurring decimal in the form of rational numbers also we have discussed, right? We have got clarity regarding periodicity and period. Okay, these things we have discussed in previous class. So by the conclusion, what we can get, every rational number can be expressed either as a terminating decimal or non-terminating repeating decimal. Okay, every rational number, you see, every rational number can be expressed as a terminating decimal or non-terminating recurring decimal. Clear? Converse is also true. That means every non-terminating recurring decimal or terminating decimal can be expressed in the form of rational number. Okay, that you have to keep in the mind. Okay, now we will move into a topic called irrational numbers. Irrational number is nothing but which cannot be expressed in p by q form, that is called irrational number. Okay, irrational number is nothing but which can't be expressed, a number which can't be expressed in p by q form. Okay, that is called irrational number, where p and q belongs to integers. P and q should be integers and q not equal to 0. Same conditions like rational number only, but irrational number means just it should not be in the form of p by q. These irrational numbers are generally denoted by q dash. We have denoted rational numbers as q, right? So irrational numbers as q dash or q bar. So what comes under irrational numbers? Simply the type 3 of decimals what we have discussed, that is nothing but non-terminating and non-repeating decimals. Non-terminating, non-repeating decimals will come under irrational numbers. Okay, non-terminating, non-repeating decimals are called irrational numbers. This is type 1. Okay, simply I will provide you one example. Okay, you can clearly see that one example like 0.010010010001. Okay, this is called non-terminating, non-repeating decimal. Okay, it is not terminating, at the same time it is not getting repeated, so that's why it is called non-terminating, non-repeating decimal. It comes under irrational number. Okay, it comes under irrational number. So you can take any such examples, 1.414141241341, like this. It is also not terminating and at the same time not repeating, so it also comes under irrational number. So you can take any decimal which is of non-terminating and non-repeating decimals, then that number will comes under irrational number. And we have one more example. You take root of 4, whether it comes under rational number or irrational number. Root of 4 in the sense we can write 2 square, you can cancel square and root, you got rational number or an integer. So if this 4 is a perfect square, right? So if you take any number like root 2 or root 3 or root 5, we cannot do like this, right? These numbers don't have any perfect squares. So any positive integer, you should not take negative numbers, only you should take positive numbers. So any positive integers, if you are taking under the root, if they don't have perfect squares like this, then that particular number will come as irrational number. Okay, this is not irrational number because it has a perfect square. 4 is a perfect square, 2 square is nothing but the root and square will get cancelled, right? So this will not come under irrational number. But you see here, root 2, root 3, root 5, these are not perfect squares. Okay, that's why this will come under irrational numbers. In the same manner, you can take perfect cubes also. Okay, fifth root of 2, fifth root of 3, fifth root of 4, all these are irrational numbers only, because they are not cubes of any other number. Clear? So these are the different types of examples of irrational numbers. You can take one more example like pi, e. Okay, but these values are very unique. These are not roots, but these are not numbers, but these are just symbols. These symbols has different values. Okay, this pi value, what is the pi value? You already know 3.14, but what is actual pi value? 3.141592655. It is never ending. In the similar manner, what is e value? 2.71, as you know, but it is actually 2.71828182. It goes on. So these are called transcendental numbers. Transcendental numbers. Irrational numbers only, but there is another name for these numbers. Those are called transcendental numbers. What is a transcendental number? Transcendental number is a number that is not a root of non-zero polynomial equation. Okay, all real numbers which are transcendental are irrational. Okay, all transcendental numbers are irrational, but converse need not be true. That means all irrational numbers need not be transcendental numbers. This is the example. Root 2, you can see root 2 or root 3, root 5. These are not transcendental numbers. This is also irrational number, this is also irrational number, but these are not transcendental numbers. Only pi, e, any specific symbols are there, those will come under this transcendental numbers. What is the definition of this transcendental number? Transcendental number is a number that is not a root of a non-zero polynomial equation. Clear? So you also note all transcendental numbers are irrational numbers, but all irrational numbers are not transcendental. Okay, there are many forms of irrational numbers, but these are enough. Okay, this is of what irrational number is. It should not be in the p by q form, and we represent it by q dash. Okay, all non-terminating, non-repeating decimals will come under irrational numbers. These are the examples, and these will also comes under irrational numbers only, but these have another name that is called transcendental numbers, and I have also told the definition of transcendental numbers. And all transcendental numbers are irrational, but all irrational numbers are not transcendental. Okay, this is the small concept of irrational numbers. Please try to remember. Okay, thank you.